Okay. Today is the first day we're actually in your 7th grade advanced textbook. Everything we've done up to now has come out of the 7th grade regular book. This is where two of them start to kind of overlap. And I wanted to take a few minutes to talk about your book and how it's laid out. Some of you are familiar with it. You used it last year or something similar to it. But maybe the teacher that you had didn't take time to explain some of the things that are there for you. I want to make sure that you know. And I'm going to tell you that sometimes the packet itself is very poorly written and we'll take very few notes in the packet. We'll take more notes with pencil and paper some days than we will using the packet. That happens. Some days, most of our notes will come straight out of the packet. But all the information that's in there is relevant to what we're learning. They may use a different method of explaining it. You take the time to read it. If it helps you, it's just one more piece of a tool to use. You'll notice that on this is actually on page, let's see where it is. Yeah, it is on page 7, isn't it? You'll see it says Lesson 1.1. It has an essential question. Obviously, this is what the whole section is about. How can you use algebraic expressions and equations to solve real-world problems? This is the Florida standard. If an administrator were to come in and said, do you know what your learning objective is today? This is, in fact, your learning objective. Students will be able to apply properties of operations as strategies to add, subtract, factor, expand linear expressions with rational coefficients. That's really what we should be looking at. Out of curiosity, right now, before we go any further, how many people would feel that they're at a 0 on our scale? They know little or nothing. How many people feel like they'd be at a 1? How many people feel like they'd be at a 2? Any at a 3? 4? Yeah, okay. Again, at the beginning of a lesson, I'd expect a lot of people to be between 0 and 2. The goal is by the end of the lesson, we should all be where?
3.
We should all be at 3, and hopefully we'll even see a few people that move themselves up to that 4, where they know something beyond what we've taken the time to teach. Again, you'll notice at the actual lesson, you see that essential question. You'll also see this. Anybody see it? There on the side of the page? If you have a smartphone that has the ability to scan that little code, this will actually pull up a video clip on how to do pieces of the lesson. So if you didn't get it from me, it gives you another resource that you can go to, and somebody else from this book company will actually be teaching it. So it's just one more tool that you can use. Okay? Today we're going to talk about how to simplify expressions. You're going to see these on your sheet of paper, and I believe these are on the bottom of page 7, but chances are there's not room to work them out. So what should you do?
Sheet of paper.
Get a sheet of paper. The problem's there, but there's not really room to work it out. You could put the answer there, but answers usually don't do us a lot of good. We need to know the steps of how to do this. Everybody ready? Okay. If you've been asked to simplify an expression, what they want you to do, obviously, is make it easier, right? Simplify. In order to make things easier, I have to put together the things that are alike. I can put x's with x's, y's with y's, numbers with numbers, but I can't put x's together with numbers. It'd be like putting apples with oranges. That's typically the one that gets used. Or apples with bananas, whoever said that. Okay? Or potatoes with apples, I don't care. If you'll notice, I see an x here, I see an x here. Who can tell me which property allows me to rewrite the order when it's all in addition? Instead of writing 3x plus a half plus 7x minus 1/4, I'd like to write 3x plus 7x plus a half minus 4 and a half. Which property is that? It is not the associative, but that was a good guess. It is not distributive. It is commutative. Commute means to go from one place to another. And when things are changing places, like they did here, we're using that commutative property. Would I typically use the commutative property, or would I just simplify it? I probably would just simplify it, but I want you to see that I'm going to put these two pieces together. What is 3x plus 7x? 10x. If I put together 1/2 and a negative 4 and a half, what's it going to give me?
5.
Negative 4. If you don't know that it's a negative 4, change them to improper fractions. A positive 1/2 minus 9/2. The negative is the larger number, and I would take 9 and I'd subtract 1 from it. So this would give me a negative 8/2, and 8 divided by 2 is 4.
Mr. Huntley, excuse me, and
Yes.
I apologize interrupting. I want to make sure I get you what you need today. So you need one more.
I need one more desk
Two
and one more,
student-
or one student desk. I mean, if we
Okay.
had one. Because
Well-
I'm going to have 25 students and only 24 places to sit.
Okay, okay. So we would hope for one of these if we could and put it right over here.
Yeah, wherever I end up putting it, I can't put it in front of my window. I'm crowded.
Okay,
No matter what, I'm crowded. One student desk would actually be better.
okay. Then that's what I'll ask.
If we can get it, that would be great.
Okay, sorry to interrupt.
Not a problem.
Good morning, Wolf. Good to see everybody.
Can I put together 10x and negative 4? Yes or no? No. This is apples. This is oranges, bananas, pineapples, I don't care, potatoes. Okay? I can't put them together, they're not the same. The reason I can't put them together is 10 is being multiplied by x. This is subtraction. What would I have to do first in order of operations? Multiplication. Unless I know what x is, I can't do the subtraction, can I? Everybody get that? Everybody good with simplifying this one? Question. I could use plus a negative 4, or I could use what? Minus 4. Either is okay. I typically write minus 4 instead of plus a negative. Typically. But it would not matter. I would not take off for either. They're both okay. Other questions?
So it would be 10 minus 4.
10x minus 4. I can't drop that x. That variable is still there. I don't know what x is. Can I solve this? I don't know what it is equal to. This is an expression, not an equation. I can express it, but I can't solve it. They have to tell me either what x is or what this expression is equal to in order to solve it. And we're going to talk about solving equations tomorrow. Okay?
So, what would be
10x minus 4. That is the answer. I know that that kind of goes against what we think. We want our answer to be a number. But in this case, we're just simplifying an expression, and our expression can have multiple variables in it. Okay? Even when you're doing a problem like this, we do have to be a little bit careful when I see a negative out in front of the parentheses. That really says a negative 1 times everything that's on the inside. That's realistically what it says. This stays the same. But if I take a negative 1 times 1.5, what would it give me? Negative 1.5. And if I take a negative 1 times 1.4, what would it give me? Negative 1.4. I've got to make sure that negative goes all the way through that parenthesis. I'm subtracting everything that's on the inside of it. But you see what I did with the negative? I'm going to combine my like terms this time without moving them. Negative 1.5 and a negative 0.25x would become what? Negative 1.75x. Negative 3 and a negative 1.4 would become what? Negative 4.4. Can I put x's together with just numbers? No. That is my answer. Pardon? Yes, I used minus or subtraction. It's minus, negative, subtract, all of it really mean what? The same thing. So call it what you need to make it easier for you to understand. We all okay? Understand what I did? Go to the next page yet? Am I good? I think you're going to find that these are on the bottom of page 8. Here we're going to use the distributive property. If I were going to distribute, in fact, I did distribute papers earlier. Did I give everybody the same amount, or did I give some people a different amount?
Different.
How many papers did you get today? 1, right? How many did you get? 1, right? 1 packet. How many did you get? 1 packet. How many did you get? Did I give everybody 1 packet?
Yes.
When you're using the distributive property, it's kind of like distributing things in a classroom. I've got to make sure everything that's inside of this group gets the same part of what's on the outside of the group. I'm going to take that 7 and I'm going to distribute it through the parentheses. I'm really taking 7 times 9k plus 7 times 6m. And I purposely wrote them different, showing that it doesn't matter which way you write them, that these both mean what? Multiplication. Would I typically write this step down? I'd tell you probably not. I would just take 7 times 9, which is what? And I'd write down 63k. And I'd take the 7 times 6, which is? And I'd write down 42m. Can I put k's and m's together? No, they're different. So that would be my answer. 63k plus 42m. Don't get confused if they throw in something like a fraction. I'm really doing the same thing. I'm taking 2/3 times 6e plus 2/3 times 9f minus 2/3 times 21g. That's what I'm doing. How many times would 3 go into 6? And 2 times 2 becomes? What happened to my fraction? It turned into a whole number. How many times does 3 go into 9?
3.
What's 2 times 3?
6.
How many times does 3 go into 21? And what's 2 times 7? Just because it has a fraction in it in the beginning doesn't mean that it'll have one in it at the end. Don't get afraid of fractions. Fractions are actually easier to work with than decimals because most of the time you can do the canceling in your head. We good?
Hold on.
I don't get what you did with the 2/3 and made it 4e.
I took 3 into 6. I crossed the 3 out because it's in the denominator. 3 went into 6 how many times? And I made the 6 a 2. 2 times 2 became what?
4.
That's where the 4e came from. I did the same thing in the next one. 3 went into 9. So this became a 1 and the 9 became a 3. 2 times 3 was 6. You okay now? Everybody understand? The 4 came from here. 3 went into 6. How many times? Twice. I crossed out the 3, really made it a 1, right? I crossed out the 6 and made it a 2 times 2 became 4. That's where the 4 came from. What was in the denominator? A 1. Do I really need it there if it's a 1 in the denominator? No, so I didn't write it.
So out of the ways that you showed us, is this the one that we can use?
Yeah, I mean, if you're using the distributive property, again, I'm not sure that I would even write this step down once I got good at doing it. I'd probably draw the little arrows like I did here. And I'd go all the way to what? This step. But I'm going to tell you the biggest mistakes that people make with the distributive property is they'll do this. 7 times 9 is 63k. And they'll write plus 6m. What's wrong with that? Lacey? They didn't finish it. Did everything on the inside get its fair share of what's on the outside? No. You have to make sure if you're distributing that everything on the inside gets its fair share of what's on the outside of the parentheses. So this one wouldn't be correct. Everybody understand the general concept? We can also use the distributive property going backwards, where we actually factor something out of it. Okay? I think you're going to find these on the bottom of the next page. Bottom of page 9. A factor is a number that is multiplied by another number to get a product. To factor is to write the number or an algebraic expression as a product. A parentheses B plus C equals AB plus AC. What do you see in each one of these two terms? An A. So I could take the A out and make it a product of A times parentheses B plus C. The distributive property works going both directions. If I take a look at number 9, what would be the greatest common factor in 2x and 2? 2. So I can make 2 a factor. What would I multiply the 2 by to get 2x? 1 what? 1x. What would I multiply the 2 by to get 2? 1. If I wanted to check my work, I could distribute it back through to make sure it gave me 2x plus 2. What's 2 times x? 2x. What's 2 times 1? 2. I can see that I'm going to get the same thing. Okay, he's got a key. Okay. For number 10, what's the greatest common factor? 3. Just set it there and I'll arrange it. I'll figure out what I got to do to get in one more desk. I am out of space, but that's what I'm getting, so. If I take a 3 out, what would I multiply 3 by to get 3x? X. What would I multiply 3 by to get 9?
3.
3. Do I need to do the other 2? Or do you guys have a good idea of how to do them now? We all good?
Yeah.
Do one more? Which one do you want me to do, 11 or 12?
11.
Huh? 12? What's the greatest common factor, David? 4. What am I going to multiply 4 by to get 4x? 1 what? What am I going to multiply the 4 by to get 16? Good? Sure. What's the greatest common factor? 5. What do I multiply 5 by to get 5x? Just what? X, right? What do I multiply 5 by to get 15? Okay? Now, if I went back to the essential question from the day, how many people still think they're at a 0? A 1? A 2? Okay, a 3? 4? Okay. Hopefully after you do the assignment and you've had a chance to practice a few problems, we'll all be at what? A 3. That's the goal. Everybody will make a what? 3.